Our previous lessons we've been looking at probability, and we've noticed how the wording is very important when we're calculating the probability. So let's think of some real-world examples to help us distinguish what we're going to have to do when we're talking about probability and statistics. So if we think about what does or mean, for example, if you were at Applebee's and you ordered the triple bacon burger, the server will ask you if you'd like French fries or onion rings. You have the choice of getting French fries or onion rings, but not both. The other example is if you were at Starbucks and you're ordering their coffee, the barista will ask you if you'd like cream or sugar. When this happens, you have the choice of cream, sugar, or both. So which use of or is correct? For our probability calculations, we're going to be going with the Starbucks or. Now the term and can be used a lot in probability. So for example, you are a senior and going to college. What does that mean? That means that the individual is a senior as well as going to college. Both events, being a senior and going to college, have to be true to be counted in this example. Now that we clarified how or is used in statistics and the word and, we're going to apply that to our situation, looking at Facebook and Twitter users. So we collected data in class the other day about this, and we filled in our two-way table. Again, our table here is identifying if you use Facebook or not, if you use Twitter or not, or if you use both. So in our first example, we talked about how many people used Twitter and Facebook and wrote that number here. The next one, we talked about how many people used Twitter and no Facebook and wrote the answer here. The upper left is talking about no Twitter, but you use Facebook. The bottom right is talking about no Twitter or Facebook. You don't use either of those. And so these were our findings. Now, totals are very important probabilities because it's the chance of that event or events happening out of the total. So I could get all of the Facebook users here by going across and the non-Facebook users here by going across. I can get the Twitter users going vertically down. I can get the non-Twitter users going vertically down. So the Twitter users have a total of 7. The non-Twitter users have a total of 7. The Facebook users was 1. The no Facebook users were 13. So I have a total of 14 people in this sample. And again, that's coming from all of the people organized. Look at your horizontal total, 14, vertical total is 14. So let's start looking at some probabilities. Here we've got a couple of questions. Suppose that we randomly chose students from this class. What would be the probabilities that they are a Facebook user, they are a Twitter user, they are not a Facebook user, they are not a Twitter user? So if we start with the first one, the probability of being a Facebook user, we had 14 individuals studied. We had one person indicate that they were a Facebook user, so that would be 1 out of 14. That's coming from the upper right-hand corner of your table. The next one was you are a Twitter user. So if we look at our table, Twitter is the left column side. You have your 7 people that use Twitter. So 7 out of 14 is 1/2, or 50%. The non-Facebook users, that is our second row of the table, and so that was a total of 13 out of 14. And our no Twitter users was a total of 7. That's coming from the second column in our table. And so again, 7 out of 14, that's a 50% chance. Now remember, these are the complement rule, looking at the chances of people using each of those apps. Now if we continue on looking at probabilities for 2 events occurring, Facebook and Twitter, Twitter and no Facebook, Facebook and no Twitter, no Facebook and no Twitter, we can still go back to the table and identify those as well. So for the first one, the probability of Facebook and Twitter, we want to look at the Facebook row at the top of our table, and we want to look at the Twitter column at the top of our table. That's our upper left-hand column, upper left-hand box in the table, which would be 0 out of 14. So we have a 0% probability. Twitter and no Facebook. Well, Twitter is the first column, no Facebook is the second row. So in the bottom right-hand corner, that would be 7 out of 14, 1/2, 50% probability. I'm looking for Facebook and no Twitter, so I'm looking at the first row of the table, the second column of the table. So that's the upper right-hand corner box. That's 1 out of 14. Probability of no Facebook and no Twitter. So no Facebook is the bottom row of our table. No Twitter is the second column of our table. Where do they meet? The bottom right-hand section. And so that's 6 out of 14, or 3/7 probability. The next question is the probability of Facebook or Twitter calculated by finding the probability of Facebook users and adding the probability of Twitter users. Why or why not? So if we're thinking about Facebook users and Twitter users, when you're looking at the table, Facebook and Twitter can coincide at the same time. They're not mutually exclusive. So I could not add those two together to get the probability because I would be double counting. So I could find the probability of Facebook users and the probability of Twitter users, but I would have to subtract those users that use both apps to find the true probability of the question being asked. So for our situation here, again, for our scenario, if we look at the Facebook users, we had 1 out of 14. The Twitter users, we had 7 out of 14. And those that used both, in our case, was 0 out of 14. But we'd still have to subtract those. So in total, the probability would be 8 out of 14. We can simplify that down to 4 out of 7. Now, the other day we talked about expressing probability in table format, in a tree diagram format. We can also talk about them in a Venn diagram format. And so here, because we're comparing the Facebook and Twitter users, we want to think about how we can transfer the information from the two-way table into this format and vice versa. So we want to think about, well, if we have some things that are happening at the same time, right? Twitter and Facebook, where would that appear in our diagram? Well, this left circle here is talking about all the Facebook users. The right circle here is talking about all the Twitter users. So if I want Twitter and Facebook, they have to overlap. So that would be this middle section here. So right in this area would be the both Twitter and Facebook. If I want Twitter or Facebook, that means either one could work. I'm looking to see those that use Facebook, so that would be this part of the circle, but notice how it said or, not and, so I'm excluding that part of the circle. Then Twitter users would be here, but it's the or part, so I'm excluding the and here. So it kind of looks like the left moon and the right moon of your picture. So here's our and section, here's our or section with the moons. So what I should be able to do is take the pieces from the two-way table and place them correctly in my diagram. So my solely Facebook user, not including Twitter, would go here. My solely Twitter user, not including Facebook, is going to go here. And the outside would be anything that doesn't fit Twitter or Facebook. So we had a single Facebook user that did not use Twitter. We had 7 Twitter users that did not use Facebook. We had 6 individuals not use Twitter or Facebook. Now remember, our total was 14 users. Well, if we add up 1, 0, 7, and 6, we get our 14 users. And that stays at 14 users, our 14 individuals that we surveyed. So as we look at the big ideas for today, looking at probabilities, this time with two-way tables and Venn diagrams versus a table format and a tree format, these are our following conclusions. When we have our two-way tables, we're typically comparing two different categories, right? And we could classify them as event A and B, so our Facebook and Twitter. So then we would have our no Facebook, no Twitter. So not A and not B. And we would arrange the values accordingly. So I just put arbitrary numbers here to talk about placements. I can take these pieces of information and transfer them to the Venn diagram. So remember, this is talking about events A and B happening at the same time, and that's your intersection of the Venn diagram. When we're talking about solely A users and not B, this section here, that top right of the box, is going to go in the left moon of your Venn diagram. Now, when I'm talking about just event B from happening, right? Just event B, not including A, this lower left-hand box of your two-way table goes in the right moon of your Venn diagram. If it doesn't qualify for either events A and B, that's on the outsides of your Venn diagram. But again, our total should come from adding all of those pieces, right? Adding all of those pieces to give you the total in your sample. We also talked about non-mutually exclusive events to avoid double counting, talk about those that classify for each, and then subtract those that would double count. If they are mutually exclusive, we don't have to worry about it. We can add the probabilities for each event and get our result that way. So with those three big ideas in mind for our probability, you are going to tackle your application 4.3, and we'll continue on tomorrow with our next lesson.